So a customer comes along needing a couple replacement parts for an RC car that were impossible to source. I was tasked with making a CAD model for them to have so they could build it themselves. The assignment seemed straightforward, but just model these components in CAD and the customer would take it from there. As part of the design process, of course, I needed to test print them. Uh, this required several attempts. I like the iterative development, whether programming during my career or building stuff with my hands. These two small parts, though, they're complicated for FDM printing, and I don't yet have an SLA printer. So printing is going to be messy and complicated, but the customer only really wants. These parts are for an RC car that I do not have access to, as it is one of those rare cars. I've split this up into upper and lower part for the video. Knowing their exact names isn't required for the commission. The customer provided the original parts, and another friend was able to provide a chassis so I could do test fits. I started with the upper assembly, considering it the more complex part. It had tricky measurements and challenges with fitting and form when I tried to align it to the chassis, but the original part was optimized for aluminum milling on a CNC machine, just unsuitable for 3D printing. Despite the challenges, after refining the measurements for a few weeks, the CAD model finally looked beautiful. Test printing was pretty hard with this one because the iterations just, there was so much thin slice areas. In the end, I figured it out. The lower assembly was way quicker to model, as it was less complicated, but after all of those first runs, I got the hang of what it was trying to do, even though it doesn't sit on the chassis perfectly. The wavy lines interface to the chassis was the real problem. The measurements taken were from the original part didn't actually align to the chassis perfectly, so I just made it as close as I could. In the end, I just had to wiggle it around, keep test printing, and eventually I got one that worked. Slicing and printing this thing was, well, as expected for FDM, a real pain in the butt because this had a double-sided, highly detailed areas, which it required supports that just totally screws up the way the faces interface. Compromises were necessary for the final test prints, resulting in an average of 45 minutes per print just to remove the supports. The final product, if printed in FDM, was half the weight of the aluminum parts, and that's apparently pretty important during racing. This commission was completed in January, sent it to the client, and that's a great way to start the year.